All right, for today, I wanted to do a quick review of exponentials versus regression. But I'm just going to show you one exponential. First of all, is it an exponential? What makes these things exponential? It's all about the exponent. So if there's an x in the exponent, it's exponential. Can you tell if this is making my 4 grow or shrink? What is it doing? Shrinking. By what percent? 7%. Do you get why that was smarter to write than this? Because then if I ask what percent is it shrinking, people go 93%. No, it's not. It's shrinking by what percent was that again? 7%. Okay. All right. And my starting amount was 4 right here. Okay, so that's like I had only 4 white rhinos left in the world, and their population has been shrinking on average 7% a year, blah, blah, blah. All right. Okay, so that's just a quick reminder about what we're doing as exponents, or exponentials. But what today we're going to focus on is weird exponents. So like, for example, if I have x squared to the negative third, I'm going to hope you'll understand by the end of today what that means. All right? All right, so that's kind of like the big picture goal. Well, let's actually get to it. Well, let's say I had x to the second to the third versus x to the second times x to the third, because that's different, and then x to the second over x to the third, as that's completely different yet. Some of you guys already know your exponent rules, and this is no big deal. On this kind, do I add them or multiply them? Multiply. So that's 6. And if you were confused, I encourage you to think about what it really means. Do you get x squared means x times x? It really means that. Do you get what I'm saying? And that means xx times xx times xx. That's what that really means. So do you get, if you look at that, you're not going to say 5 by accident. If you write it all out, you'll see what it means is there's 6 of them. 6. So if you ever get stuck and you're like, oh, what does this one mean? Write it out in exploded form. All right, so this next one, should I have x to the 5th or x to the 6th? Now you can see it from context that this must be different, but what if I wrote out what it really means? Wouldn't this mean xx? Wouldn't this mean xxx? And it's a times in the middle? If you write that out, would you think you would write x to the 6th? I hope you'd be smart enough to go, that'd be x to the 5th. Get what I mean? My point is you're going to forget sometimes. So have a strategy, which is write it out in exploded form, and it'll be obvious that, oh, in this kind, I add them. And on the next kind, if I have multiplied, I have added, what do you think this kind does? Subtract x to the negative 1. What? That's right, actually. But you'll find that any math teacher will tell you, you can't leave your answer with negative exponents in it. Negative exponents are a thing, but they are not simplified all the way. That is 1 over x. That is correct. Somebody was showing me that with their hands. Yes, it's 1 over that. Okay, here's a way to think of it. What does this really mean? XX. What does this really mean? XXX. And watch what happens. Cancels. Cancels. There's 1x left on the bottom. And there will be what on top? A 1. Because technically, when these are canceling, they're all turning into 1s. It's 1 over x. So if you ever get stumped, you can always write out what it really means. All right, then the last thing I have for you is, what if you have something with negative exponents, but it's in a fraction? Well, you can still do the rule where it's this minus this. So that's x to the negative 2 minus negative 5, which means negative 2 plus 5, which means to the third. Cool. Another way to do this is, same exact problem. If it has negative exponents, you can move it to the other side of the fraction and make it have positive exponents. And then this guy He's unhappy. He's negative. Get what I'm going there? That's negative. I'm going to make it happy by moving it to the bottom, x to the second. And now it's like x to the positive 5 over x to the 2. By moving it to the other side of the fraction bar, you're making it happy. And then what do I do with these? 5 minus 2 is x to the third. Now, the reason I like that way is because a lot of times your problems go like this. Or maybe it isn't even an x. Maybe it's like an m to the negative second. I just think to myself, okay, I'm going to make this one happy and move it up here, and it's going to be m to the positive second. There, I'm done. Problem's over. If you just move it to the other side, it'll make it happy. I often give this example. In Florida, my dad used to live in the bottom floor of a condo, but there was a top floor of the condo. Get how it's kind of like a big fraction bar? And in the condo, there were always people who thought their side of the condo, the upper ones or the lower ones, were better. Like, oh, you really want to get an upper unit because, why do you think? Why do people like the upper level ones? What would they be saying? The view. A little up, a little higher gives you a further view. Good. What else do you get on the upper level condos? Yes. That's true. There's nobody above you, and it's very true. If you've ever lived in that situation with somebody above you, them walking around on the floor, like we stayed at a condo in Hawaii where there was somebody who living above us, and then when they woke up in the morning at 4 a.m., we're walking around in the condo above us, and the floor would crack and creak. It was like waking us up. And anyway, so that's true. You'll have nobody above you if you're on the top. All right, so there's some benefits to living on the top. If you're really old, it's better to live on the bottom. Why? Don't have to climb up the stairs, especially with a bag of groceries. If you're old and your knee hurts and you're carrying this bag of groceries and you got a cane, can you imagine what a pain it is to go up the stairs? See what I mean? So for some of the older folks, downstairs is better. All right, so enough examples, but let's say I got this. Think of it as an unhappy old person. Move them where they're going to be happy. Just put them down here and they'll be x to the third and they'll be happy. All right, it's just a dumb little trick, but it works for me. It's worked for a lot of kids, so you might like that one. All right, so to sum it all up, here's a typical question. Your final answer has numbers, a's, and x's. It might be like 7a to the 5th, x to the 3rd. Write out what you think the answer to that one is. Pause for a second while you give it a try. Okay. Did you take the 3 and square it and get 9? Raise your hand if you have a 9 in your answer. Awesome. A lot of people forget that. They worry about the a, but they don't even think about the 3. All right. Next, a squared has to get squared, which makes a to the, well, actually, this is a bad example because you could have added them or multiplied them, and either way, you should add a to the 4th. I hope nobody gets that wrong. What you really should have been doing is multiplying, though. Okay, and then these guys, I like to think of it as they're unhappy. Let's move them up to the top, where they'll be happy. Raise your hand if you had that one right. Awesome. Okay, here's one more complicated one. 2 a to the 3rd, y to the negative 2nd, all to the negative 2nd. Everything that got put to a negative power needs to move so it can be happy. Is one way to think of it. Another way to think of it is just multiply them all out, and then everything that's got a negative power at the end, fix it. All right, I'm going to pause this for a second and see how you do. Okay, I had this good question about negative exponents. Like that, for instance. Is the answer going to come out negative or positive? Positive. It just moves where it is. Now, it's 9 squared, so that's what? No, what? It's 81. So if it's 81, can I just leave it as 81? No. But I don't make it negative. I make it, what? 1 over 81. Okay, awesome. All right, good enough on that. Back to this. 2 to the negative second. Does it make the 2 negative? No. 2 squared is 4, and then it moves to the other side, so it's down there. Raise your hand if you had a 4 in the right spot. Awesome. Now, the a to the third to the second, could I just multiply them and say it's a to the negative 6? Yep. But then you got to move it because it isn't happy where it is. So hopefully you moved it downstairs and made it a to the 6th. Yes? Okay. I get what you're saying. Let me just finish this. He asked a question about the 0.25, and there isn't a 0.25 in this, but there can be if I do it a different way. All right, this is y to the, well, I multiply them, makes it positive 4. That's on the top. A lot of people goof that up and put it on the bottom. It's not on the bottom. Just think about it. Multiply those two together. Doesn't that just make positive 4? But you might be saying, but it has a negative exponent, so it should move. Not if you do it where you multiply them together first. Otherwise, you can think of it as it starts on the bottom and the negative exponent moves it to the top. Either way, final answer is that y to the 4th is on the top. Now, if I put a 1 here, which nobody would argue is like this, not illegal, right? Then do you see why he's talking about 1/4 being 0.25 or 1/4? Could that be a 0.25? Yeah. I could, instead of saying 1/4, I could say 0.25. But where would it go? On the bottom? No. It'd be on the top. Because a 0.25 on the bottom would be like saying I have a 1/4 on the bottom, and that wouldn't be right. Okay. So yeah, you could have a 0.25, but it would have to be on the top. All right, we are down to 12 minutes left. It's a great reminder to get out your worksheet that is assigned for tonight. If you look, there's a folder with today's date on it, which is the 14th. Happy Valentine's Day. And we're going to do, it's kind of an odd day, right, with all these singing telegrams and stuff. So we're doing the odds. Let's do the odd problems on that worksheet. I'm going to pause for a second. We can find that. Again. Okay, so here we are on 2-14, Properties of Exponents. And I'm going to go to the homework. And within that, I'm going to open the worksheet. And we said we do the odds because it was kind of an odd day. And I'll do the control roller ball to zoom in on it. I'm doing something wrong. Weird, that worked in my other class. That's not working here. Guess I can go up here. Okay, so for this one, you got two choices. You can either move them first and then put them to the 4th, or you can put them to the 4th right away and then move them. So this is x to the negative 8th and then move it, makes it 1 over x to the 8th. There, I just did the x part. Wait a minute, there's more x's. I'm going to do those separately. That is x to the negative 12th. And that means if it was x down here, they'd be happy, so they'd be positive, right? And then I'm going to put them together, and I get 1 over x to the, do you know how to do this kind? Do you multiply or do you add? Add. Could you have done that a faster way? Sure, especially now that I see the answer. I could have just said, these together make x to the positive, because the negatives cancel, and you multiply those? No, you add those. Wait a minute. No, that would be x to the negative 5, sorry. And then I put it to the 4th. And then I multiply it out, and I get x to the negative 20th. And then I'm smart enough not to leave it that way, because you can't have negative exponents. So then it's 1 over x to the 20th. Either way, the answer is 1 over x to the 20. Okay, one more thing that's going to come up is, what if you just have a negative 1 power? That just puts it in the bottom and moves it to the bottom of the fraction. Or it makes it 1 over that. And the last thought, how about things that are to the 0 power? Do you remember that anything to the 0 is equal to not 0, it's equal to 1. Anything to the 0 power, even if it was like 2x to the 0, with parentheses around it, that would be 1. Here's one exception the kids get all twisted on. They're like, oh, so this all equals 0. Nope. It doesn't all equal 1 either. This part would equal 1, and then you times by 3, so that would actually equal 3. Okay, there you go. There's all your weird exponent exceptions. We haven't done fraction exponents, though. That's going to get weirder. And that's what's probably coming next. And that's all I got for you for today. Just do the odd ones on this worksheet.